Question 1. During the development of an environmental product declaration, EPT for a new industrial solvent, the life cycle assessment LCA identified the release of 0.05 kg of a specific hydrochlorofluorocarbon HCFC during the product's use phase. The established characterization factor for this HCFC contribution to ozone depletion relative to CFC11 is 0.03. According to the principles of ISO 14028, 2016 regarding the transparent reporting of environmental impacts, what is the calculated ozone depletion potential contribution of this specific emission event that must be accurately reflected in the EPD? Option A, 0.053 kg ODP equivalent. Option B, 0.02 kg ODP equivalent. Option C, 0.08 kg ODP equivalent. Option D, 0.0015 kg ODP equivalent. The correct answer is D, 0.0015 kg ODP equivalent. Explanation: ISO 14028-2016 provides guidelines for the development of environmental product declarations, EPD. While the standard itself doesn't mandate specific impact categories, it emphasizes the importance of using scientifically sound life cycle assessment, LCA, methodologies to quantify environmental impacts. Ozone depletion potential ODP is a recognized environmental impact category within LCA, typically assessed using methods like those outlined in ISO 14040 and ISO 14044. The development of an EPD requires transparent reporting of the LCA results, including the chosen impact assessment methods and characterization factors. For ODP, the characterization factor quantifies the relative contribution of a substance to ozone depletion compared to a reference substance, typically CFC11. For example, if the LCA for a product identifies the use of a refrigerant with an ODP characterization factor of 0.8 relative to CFC11, and the total mass emitted over the product's life cycle is 0.1 kg, the contribution to ozone depletion would be calculated as mass emitted multiplied by the characterization factor, \0, 1 text kg times 0.8 equals 0.08 text kg ODP equivalent \. This value, along with other relevant impact categories, will be reported in the EPD. The selection of the appropriate characterization factors and the transparency in their application are crucial for the credibility of the EPD, ensuring that stakeholders can accurately interpret the environmental performance related to ozone depletion. The standard encourages the use of widely accepted and scientifically validated characterization factors. Question 2. Consider a manufacturer developing an environmental product declaration for a novel bio-based composite panel. The LCI phase for this product involves sourcing sustainably grown bamboo, processing it with a bioresin binder, and manufacturing the panels. Which of the following accurately describes the most critical consideration for the life cycle inventory, LCI phase of this EPD, in alignment with ISO 14028-2016 guidelines, ensuring the declaration's integrity and comparability? Option A, focusing solely on the energy consumption during the panel manufacturing process, as this is typically the most significant operational cost and environmental impact for composite materials. Option B, prioritizing the collection of data related to the biodegradability of the bioresin binder, as this is a key differentiator for bio-based products and a primary concern for end-of-life management. Option C, ensuring the LCI data comprehensively quantifies all environmental inputs and outputs across the entire life cycle of the bio-based composite panel, including raw material extraction, processing, transportation, use, and end-of-life, with transparent and justifiable allocation procedures for co-products and recycled content. Option D, relying exclusively on generic industry average data for bamboo cultivation and bioresin production to expedite the LCI process and reduce data collection burdens. The correct answer is C, ensuring the LCI data comprehensively quantifies all environmental inputs and outputs across the entire life cycle of the bio-based composite panel, including raw material extraction, processing, transportation, use, and end-of-life, with transparent and justifiable allocation procedures for co-products and recycled content. Explanation: the development of an environmental product declaration, EPD, according to ISO 14028-2016, necessitates a robust life cycle inventory, LCI analysis. The LCI is the foundational data gathering phase that quantifies all relevant environmental inputs and outputs of a product system throughout its life cycle. This includes resource extraction, manufacturing processes, transportation, use, and end-of-life management. For a product like a bio-based composite panel, the LCI would meticulously track the biomass cultivation, e.g., energy for farming, water use, fertilizer inputs, land use change impacts, processing of the biomass into raw materials, e.g., energy for drying, grinding, binder production, panel manufacturing, e.g., energy for pressing, emissions from adhesives, transportation to distribution centers and end users, the use phase, e.g., potential off-gassing, durability impacting replacement frequency, and finally, end-of-life scenarios such as landfilling, incineration, or recycling. The selection of appropriate data quality and allocation procedures is paramount. ISO 14028 emphasizes using data that is representative of the actual product system, considering geographical relevance and temporal relevance. Allocation, the process of dividing environmental burdens among co-products or recycled materials, requires careful consideration and transparency. For instance, if the biomass cultivation also yields a secondary agricultural product, the environmental burdens associated with cultivation must be allocated between the panel material and the secondary product. Similarly, if recycled content is used, the allocation of burdens from the original product's life cycle needs to be defined. The goal of the LCI is to provide a comprehensive, quantifiable inventory of environmental flows, which then serves as the basis for the Life Cycle Impact Assessment (LCA) and the subsequent EPD. The accuracy and completeness of the LCI directly influence the credibility and utility of the final EPD. Therefore, the most critical aspect is ensuring the LCI data accurately reflects the entire life cycle of the bio-based composite panel, including all upstream and downstream processes, with transparent and justifiable allocation methods. Question 3. Considering the procedural requirements for developing an environmental product declaration, EPD, compliant with ISO 14025, what is the indispensable prerequisite for initiating the life cycle assessment, LCA, and subsequent declaration process for a new line of biodegradable cleaning agents? Option A. A completed internal risk assessment of the product's environmental impact throughout its life cycle. Option B. The existence of a publicly available product category rules, PCR, document specifically developed for biodegradable cleaning agents. Option C. A comprehensive market analysis demonstrating consumer demand for EPD-certified cleaning products. Option D. Formal approval from a national environmental protection agency for the proposed EPD content. The correct answer is B. The existence of a publicly available product category rules, PCR, document specifically developed for biodegradable cleaning agents. Explanation. The question pertains to the foundational principles of environmental product declarations, EPD, as outlined in ISO 14025. ISO 14025 establishes the framework for Type I, Type Roman II, and Type Roman III environmental declarations. Type Roman III environmental declarations, often referred to as EPDs, are voluntary, multi-criteria, and provide quantified environmental information based on life cycle assessment, LCA. A critical aspect of EPD development is the establishment of product category rules, PCR. PCRs are crucial for ensuring comparability and consistency in EPDs for similar products by defining the calculation rules, system boundaries, and data requirements for the LCA. Without a relevant and established PCR, the development of a credible and comparable EPD is not possible according to the ISO 14025 standard. The standard emphasizes that PCRs are developed by program operators or industry consortia to ensure that the LCA results are relevant, transparent, and can be compared across different products within the same category. Therefore, the prerequisite for creating an EPD under ISO 14025 is the existence of a PCR that covers the specific product category. Question 4. When developing an environmental product declaration, EPD, following the principles outlined in ISO 14028-2016, what specific environmental impacts are deliberately excluded from a cradle-to-gate system boundary analysis? Option A. Impacts associated with product use, distribution beyond the manufacturing facility, and end-of-life disposal. Option B, impacts from the procurement of primary and secondary raw materials and all internal factory logistics. Option C, impacts from raw material extraction and manufacturing processes, but including product packaging. Option D, impacts related to transportation of raw materials to the manufacturing site and energy consumption during production. The correct answer is A, impacts associated with product use, distribution beyond the manufacturing facility, and end-of-life disposal. Explanation: ISO 14028-2016, specifically within its guidelines for developing environmental product declarations (EPD), emphasizes the importance of clearly defining system boundaries. When a cradle-to-gate assessment is employed for an EPD, it encompasses all environmental impacts associated with a product from the extraction of raw materials through to the point where the product leaves the manufacturing facility. This includes the procurement of raw materials, the manufacturing processes, and any transportation involved in getting the product to the factory gate. However, it explicitly excludes the use phase of the product and its end-of-life treatment. Therefore, impacts related to the distribution beyond the factory gate, consumer use, maintenance, and disposal are not accounted for in a cradle-to-gate EPD. This limited scope is crucial for comparability and transparency, ensuring that stakeholders understand precisely which life cycle stages are included in the environmental assessment. The standard mandates that the selected system boundary must be clearly communicated in the EPD to avoid misinterpretation. Question 5. Consider a manufacturing facility that produces high-grade insulation material and, as a co-product, a significant quantity of recycled plastic pellets from a separate, integrated recycling line that processes post-consumer waste. The insulation material is the primary product, and the recycled plastic pellets are sold to another industry. According to the principles outlined in ISO 14028-2016 for environmental product declarations, how should the environmental burdens associated with the initial processing of the post-consumer waste into recycled plastic pellets be allocated when developing the EPD for the insulation material, if the recycled plastic pellets are considered a co-product of the overall manufacturing operation? Option A. All environmental burdens from the recycling process, including the original production of the waste material, should be fully allocated to the insulation material to reflect the integrated nature of the facility. Option B. Environmental burdens of processing the post-consumer waste into recycled plastic pellets should be allocated to the recycled plastic pellets based on their market value or mass, and not directly transferred to the insulation material's EPD. Option C. A portion of the environmental burdens associated with the original production of the post-consumer waste should be reallocated to the insulation material to account for the shared manufacturing infrastructure. Option D. The environmental burdens of processing the post-consumer waste should be disregarded in the insulation material's EPD as it is a separate recycling operation, even if integrated. The correct answer is B. The environmental burdens of processing the post-consumer waste into recycled plastic pellets should be allocated to the recycled plastic pellets based on their market value or mass, and not directly transferred to the insulation material's EPD. Explanation: the fundamental principle for allocating environmental burdens to co-products in an environmental product declaration, EPD, under ISO 14028-2016, particularly when considering recycling, is to ensure that the allocation reflects the economic value or mass of the co-products. When a primary product and one or more co-products are generated from a single process, the environmental burdens associated with that process must be distributed among them. ISO 14028-2016 emphasizes that the method of allocation should be justified and transparent. For recycling, when materials are recovered and re-enter a production system, the allocation should prevent the recycling of waste burden from being unfairly placed on the primary product or the recycled material itself. The standard suggests that the environmental burdens associated with the recycling process itself, e.g., collection, sorting, reprocessing, can be allocated to the recycled product. However, the burdens of the original production of the material that is now being recycled are typically not reallocated to the new product. Instead, the system boundary for the recycled product's EPD should commence at the point of recycling. Therefore, when a material is recycled and becomes a co-product or input for a new product. The allocation of the original production burdens should be managed to avoid double counting and to accurately represent the environmental profile of the new product. The most robust approach, aligned with ISO 14028, is to allocate the burdens of the recycling process to the recycled material, and to consider the original production burdens as accounted for in the life cycle assessment of the product from which it was recycled, or to use a system boundary that starts at the recycling input. This avoids transferring the environmental burden of the original product's creation to the new product derived from recycled content. Question 6. When developing an environmental product declaration, EPD, for new type of composite building material, what critical step, as outlined by ISO 14028-2016, is essential to ensure its comparability with existing EPDs for similar materials, and to facilitate informed decision-making in procurement processes governed by regulations like the EU's Green Public Procurement (GPP) criteria? Option A. Presenting a simplified summary of the LCA results without disclosing the full methodology or data sources used. Option B. Establishing or adhering to a relevant product category rule (PCR) that specifies the LCA methodology and reporting requirements for composite building materials. Option C. Securing an EPD certification from a national environmental agency without prior verification of the underlying LCA data. Option D. Focusing solely on the end-of-life environmental impacts of the material, ignoring upstream and manufacturing stages. The correct answer is B. Establishing or adhering to a relevant product category rule (PCR) that specifies the LCA methodology and reporting requirements for composite building materials. Explanation. The core principle of ISO 14028-2016 is to ensure that environmental product declarations (EPD) provide credible and comparable environmental information. This standard guides the development of EPDs, which are Type Roman III environmental declarations. These declarations are based on life cycle assessment (LCA) data and are verified by a third party. The purpose is to communicate environmental performance in a transparent and standardized manner across different product categories and industries. A key aspect is the establishment of product category rules (PCR), which are essential for ensuring comparability of EPDs for similar products. PCRs define the specific LCA methodology, system boundaries, data requirements, and reporting formats to be used for a particular product group. Without consistent PCRs, EPDs for similar products could be based on different assumptions and methodologies, rendering them incomparable and undermining their utility for informed decision-making by consumers, businesses, and policymakers. Therefore, the existence and adherence to relevant PCRs are fundamental to the integrity and effectiveness of EPDs as a tool for environmental communication and market transformation, aligning with the overarching goals of environmental labeling and declarations. Question 7. A manufacturer of solar photovoltaic modules is developing an EPD according to ISO 14028-2016. Their primary manufacturing facility is in Germany, but a significant portion of the raw materials, specifically polysilicon, is sourced from a supplier in China with a considerably different energy grid composition. The PCR for photovoltaic modules requires data to cover the entire supply chain and production. What approach best addresses the data representativeness and completeness requirements for the polysilicon component in the EPD? Option A. Collect detailed life cycle inventory data solely from the Chinese supplier, without considering the global average or the German operational context. Option B. Exclusively use data from the German manufacturing facility's energy and material inputs, assuming this is representative of the entire supply chain. Option C. Utilize the average environmental data for polysilicon production globally, clearly stating the geographical scope and any significant deviations from the German facility's operational context. Option D. Employ data from the German facility for all life cycle stages, including the upstream polysilicon production, and omit any specific mention of the Chinese sourcing. The correct answer is C. Utilize the average environmental data for polysilicon production globally, clearly stating the geographical scope and any significant deviations from the German facility's operational context. Explanation. The core principle of data representativeness and completeness in the context of ISO 14028-2016 is to ensure that the information presented in an environmental product declaration, EPD, accurately reflects the environmental performance of the product over its entire life cycle, as defined by the relevant product category rules, PCR. This involves collecting data that is both geographically and temporally relevant to the product's production and use phases. Completeness dictates that all significant environmental impacts across all life cycle stages, as specified by the PCR, must be accounted for. Representativeness ensures that the data used is not biased and truly mirrors the typical product or process. For instance, if a product's manufacturing is spread across multiple continents with varying energy mixes and regulatory frameworks, the EPD data must aggregate or appropriately represent these differences, rather than relying solely on data from a single, potentially unrepresentative, location. This is crucial for comparability and credibility, preventing greenwashing and ensuring that stakeholders can make informed decisions based on a holistic environmental profile. The standard emphasizes that data should be of sufficient quality and detail to support the claims made in the EPD, and any limitations or assumptions must be clearly documented. Question 8. When initiating the development of a product category rule, PCR, for a novel composite material intended for sustainable building construction, what procedural element, as guided by ISO 14028-2016, is most critical for ensuring the PCR's future acceptance and scientific defensibility among diverse market participants and regulatory agencies? Option A. Prioritizing the immediate adoption of the most recently published life cycle assessment, LCA methodology, even if it has not yet undergone extensive peer review or market validation for this specific product category. Option B. Limiting stakeholder consultation to only those entities with direct commercial interests in the composite materials production to streamline the development process. Option C. Focusing solely on the functional unit and system boundaries without engaging external parties to ensure objectivity and prevent external influence on the technical specifications. Option D. Establishing a formal consensus-building mechanism that actively solicits and integrates feedback from a broad spectrum of identified stakeholders, including material suppliers, end users, environmental advocacy groups, and relevant governmental oversight bodies. The correct answer is D. Establishing a formal consensus-building mechanism that actively solicits and integrates feedback from a broad spectrum of identified stakeholders, including material suppliers, end users, environmental advocacy groups, and relevant governmental oversight bodies. Explanation: the development of a product category rule, PCR, is a foundational step in creating environmental product declarations, EPD. ISO 14028-2016 emphasizes the importance of a robust and transparent PCR development process, which necessitates broad stakeholder engagement. Stakeholders include manufacturers, purchasers, regulatory bodies, scientific experts, and environmental organizations. Their input is crucial for ensuring the PCR is scientifically sound, relevant to the product category, and addresses the concerns of various user groups. A key aspect of this engagement is the consensus-building process. This involves actively seeking and incorporating feedback from all relevant parties to achieve agreement on the methodologies, impact categories, and data requirements for the EPD. Without this broad consensus, the resulting PCR may lack credibility and acceptance across the market, potentially leading to disputes or limited adoption of EPDs based on it. Therefore, a structured approach to identifying, consulting, and integrating stakeholder perspectives is paramount for the successful and defensible development of a PCR, aligning with the principles of Type I, Type Roman II, and Type Roman III environmental declarations as outlined in the ISO 14020 series. Question 9. When developing an environmental product declaration, EPD, for a new composite material, what fundamental principle of data management, as implicitly guided by ISO 14028-2016's emphasis on robust verification, must be rigorously addressed during the initial data collection and analysis phases to ensure the eventual EPD's credibility and compliance with the standard's intent? Option A. Focusing solely on the operational phase of the product's life cycle, as this typically contributes the most significant environmental impacts according to general LCA principles. Option B. Prioritizing the use of publicly available secondary data for all life cycle stages to minimize the burden and cost associated with primary data acquisition. Option C. Implementing a flexible data structure that allows for frequent updates and modifications to the EPD without requiring a full re-verification process. Option D. Ensuring that all collected data, from raw material extraction to end-of-life scenarios, is traceable to its source and accompanied by documented assumptions and methodologies used in its generation. The correct answer is D. Ensuring that all collected data, from raw material extraction to end-of-life scenarios, is traceable to its source and accompanied by documented assumptions and methodologies used in its generation. Explanation: ISO 14028-2016, which provides guidelines for the development of environmental product declarations, EPD, emphasizes the critical role of data validation and verification to ensure the credibility and reliability of the information presented. The standard outlines that the development of an EPD requires a rigorous process of data collection, calculation, and reporting, all of which are subject to scrutiny. Verification of an EPD involves an independent third-party review to confirm that the EPD complies with the relevant ISO standards, including ISO 14025, Type Roman III Environmental Declarations, and ISO 14040/14044, Life Cycle Assessment. This verification process is essential for establishing trust among stakeholders, including consumers, regulators, and business partners. The validation of the underlying data, which forms the basis of the EPD, is a prerequisite for the overall verification. This includes checking the accuracy, completeness, consistency, and relevance of the data used in the life cycle assessment, LCA, calculations. The standard suggests that the data validation process should address the quality of both primary and secondary data, ensuring that it meets predefined criteria for reliability and representativeness. The ultimate goal of these processes is to provide transparent and verifiable environmental information about a product or service. Question 10. When establishing product category rules, PCR, for a novel bio-based composite insulation panel intended for residential construction, what is the most critical aspect of defining the product category scope to ensure the integrity and comparability of subsequent environmental product declarations, EPD, according to ISO 14025 guidelines? Option A. Precisely delineating the system boundaries and functional unit, encompassing raw material sourcing for the bio-based feedstock, composite manufacturing processes, transportation, installation, use phase energy performance contribution, and end-of-life scenarios. Option B. Limiting the scope to the cradle-to-gate perspective, excluding the installation, use, and end-of-life phases to simplify the LCA process and reduce data collection requirements. Option C. Specifying the visual aesthetic characteristics and fire resistance ratings of the insulation panel, as these are key selling points for consumers, irrespective of their direct LCA relevance. Option D. Primarily focusing on the manufacturing phase of the composite panel, including energy consumption and waste generation at the production facility, while deferring detailed analysis of upstream and downstream impacts. The correct answer is A. Precisely delineating the system boundaries and functional unit, encompassing raw material sourcing for the bio-based feedstock, composite manufacturing processes, transportation, installation, use phase energy performance contribution, and end-of-life scenarios. Explanation: the development of an environmental product declaration, EPD, under ISO 14025 requires a clear and robust definition of the product category. This definition is foundational for conducting a life cycle assessment, LCA, which underpins the EPD. ISO 14025 emphasizes that the product category rules, PCR, must clearly delineate the system boundaries and functional unit for the product category. For a composite material like a bio-based insulation panel, defining the product category scope involves specifying what is included within the cradle-to-grave or cradle-to-gate assessment. This includes raw material extraction and processing, manufacturing of the panel, transportation, installation, use phase, e.g., energy savings attributed to insulation, and end-of-life disposal or recycling. The scope must be sufficiently detailed to ensure comparability between different EPDs for similar products. Crucially, it must define the specific bio-based feedstock, the manufacturing processes involved in creating the composite, and the intended applications of the insulation. The PCR should also address how to account for any binding agents or additives used in the composite. Without a precise definition of the product category, including its functional unit and system boundaries, the LCA results would be incomparable, and the EPD would lack the necessary transparency and credibility required by ISO 14025. The scope must clearly articulate whether the EPD covers the product as sold, installed, or in use, and what specific environmental impacts are being quantified. Question 11. A manufacturer is developing an environmental product declaration, EPD, for a new type of biodegradable packaging material, adhering to the principles outlined in ISO 14028-2016. Their life cycle assessment, LCA, reveals significant impacts across several environmental categories, including global warming potential, acidification potential, and eutrophication potential. The marketing department suggests that to present a more favorable overall environmental profile, they should assign higher subjective weights to categories where their product performs exceptionally well and lower weights to those where performance is less competitive, subsequently aggregating these weighted scores into a single environmental performance index. How should the EPD development team proceed with interpreting and presenting these LCA results in accordance with ISO 14028-2016? Option A. Select only the impact categories where the product demonstrates the most favorable results and exclude all other categories from the EPD to streamline the communication of environmental performance. Option B. Develop a proprietary weighting system based on the marketing department's perceived importance of each impact category to ensure a positive public perception of the product's environmental benefits. Option C. Combine all impact category results into a single numerical score using a predefined, publicly available weighting scheme, even if that scheme does not fully align with the specific product's life cycle stages or regional environmental priorities. Option D. Present the results for each significant impact category individually and transparently, without applying subjective weighting or aggregation that could create a misleading overall impression. The correct answer is D. Present the results for each significant impact category individually and transparently, without applying subjective weighting or aggregation that could create a misleading overall impression. Explanation. The core principle of ISO 14028-2016 is to provide a framework for developing environmental product declarations, EPD, that are credible, comparable, and transparent. When interpreting life cycle assessment, LCA, results for an EPD, particularly concerning the selection of impact categories and their weighting, the standard emphasizes objectivity and avoidance of arbitrary choices that could mislead stakeholders. ISO 14028-2016, aligned with ISO 14040 and ISO 14044 series, mandates that the selection of impact categories and the methods used to quantify them should be scientifically sound and relevant to the product's environmental profile. Furthermore, any use of weighting or aggregation of impact categories must be transparently disclosed and justified, typically through reference to established methodologies or standards that have undergone public consultation. The standard cautions against subjective weighting schemes that might artificially favor certain environmental aspects over others, thereby compromising the overall integrity and comparability of the EPD. The goal is to present a comprehensive environmental profile based on robust scientific data and established impact assessment methods, rather than a manipulated or selectively highlighted set of results. Therefore, the most appropriate approach for interpreting LCA results for an EPD under ISO 14028-2016, when faced with multiple significant impact categories, is to present the results for each category individually and clearly, avoiding any form of subjective aggregation or weighting that could distort the overall environmental performance. Question 12. When establishing product category rules, PCR, for a novel composite material used in construction, what is the most crucial consideration to ensure the PCR's integrity and the subsequent comparability of environmental product declarations, EPD, within this emerging market, especially when existing PCRs for similar materials are limited and subject to ongoing research regarding their life cycle impacts? Option A. The inclusion of a broad range of secondary environmental indicators, such as visual aesthetics and user comfort, even if their quantification within an LCA framework is not well established by current scientific consensus. Option B. The rigorous alignment of the PCR development process with the principles and methodologies outlined in the ISO 14040 and ISO 14044 standards for life cycle assessment, ensuring a scientifically sound and consistent foundation for all subsequent EPDs. Option C. The prioritization of data collection exclusively from manufacturers within the target market to ensure immediate industry buy-in and reduce the complexity of the initial PCR document. Option D. The immediate adoption of the most stringent environmental performance benchmarks reported in early-stage academic studies to establish a highly ambitious target for the new product category. The correct answer is B. The rigorous alignment of the PCR development process with the principles and methodologies outlined in the ISO 14040 and ISO 14044 standards for life cycle assessment, ensuring a scientifically sound and consistent foundation for all subsequent EPDs. Explanation: the development of product category rules (PCR) under ISO 14028-2016 is a critical process for ensuring the comparability and credibility of environmental product declarations (EPD). A fundamental principle guiding PCR development is the adherence to ISO 14040 and ISO 14044 series for life cycle assessment (LCA). These standards provide the framework for conducting LCA, including goal and scope definition, inventory analysis, impact assessment, and interpretation. When developing PCRs, particularly for a new or evolving product category where existing guidance is scarce, the primary objective is to establish a robust and transparent methodology that minimizes subjectivity and ensures consistency across different EPDs for similar products. This involves defining clear system boundaries, selecting appropriate impact categories and characterization factors, and specifying data quality requirements. The challenge lies in balancing the need for comprehensiveness with practicality, ensuring that the PCR is usable and that the resulting EPDs are meaningful to stakeholders. A PCR should not arbitrarily exclude significant environmental impacts or rely on data that cannot be reliably obtained or verified. The process necessitates engagement with relevant stakeholders, including manufacturers, industry associations, and regulatory bodies, to ensure that the developed rules are scientifically sound, industrially relevant, and legally compliant with any applicable national or international environmental regulations that might influence product lifecycle assessments or declarations. The goal is to create a consensus-based document that facilitates the creation of EPDs that are accurate, comparable, and contribute to informed decision-making by consumers and businesses. Question 13. Consider the development of an environmental product declaration for a high-performance industrial valve designed for diverse applications across chemical processing and energy sectors. The manufacturer aims to highlight the environmental efficiencies achieved during its production. Which system boundary justification would be most aligned with the principles of ISO 14028-2016 for this specific objective, considering the variability in downstream use and disposal? Option A. A cradle-to-gate boundary is appropriate because it focuses on the environmental burdens from raw material extraction and processing through to the finished product at the factory gate, effectively isolating the manufacturing impacts from the highly variable use and end-of-life phases. Option B. A cradle-to-grave boundary is necessary to capture all potential environmental impacts, including the significant energy consumption during operation and the complex disposal scenarios common in industrial settings. Option C. A cradle-to-cradle boundary is mandated to ensure that the product's recyclability and potential for closed-loop systems are fully accounted for, reflecting a commitment to circular economy principles. Option D. A gate-to-gate boundary is the most suitable as it concentrates solely on the internal manufacturing processes within the company's operational control, excluding upstream supply chain and downstream customer impacts. The correct answer is A. A cradle-to-gate boundary is appropriate because it focuses on the environmental burdens from raw material extraction and processing through to the finished product at the factory gate, effectively isolating the manufacturing impacts from the highly variable use and end-of-life phases. Explanation: the selection of system boundaries for an environmental product declaration, EPD, under ISO 14028-2016 is a critical step that dictates the scope of environmental impacts assessed. ISO 14028 emphasizes that system boundaries should be justified based on the product's life cycle stages, potential environmental relevance, data availability, and the intended use of the EPD. For a manufactured component like a specialized industrial valve, a cradle-to-gate approach is often appropriate if the primary focus is on the manufacturing process and the environmental impacts associated with raw material extraction, processing, and the manufacturing itself. This approach excludes the use and end-of-life phases, which might be highly variable depending on the specific application and disposal methods of the valve, and thus could introduce significant uncertainty or complexity that detracts from the core manufacturing performance. The justification for excluding the use phase would typically center on the diversity of operational conditions, maintenance requirements, and potential energy consumption across various industrial settings, making a generalized assessment challenging. Similarly, end-of-life considerations are often excluded when the primary goal is to compare manufacturing efficiencies or material sourcing, especially if recycling or disposal pathways are not standardized or are beyond the direct control of the manufacturer. The standard requires that any exclusion of life cycle stages or specific processes be clearly documented and justified within the EPD to ensure transparency and comparability. The selection of a cradle-to-gate boundary, therefore, aims to provide a focused and defensible assessment of the product's environmental footprint up to the point of sale. Question 14. When developing an environmental product declaration, EPD, for a novel biocomposite material, a critical step involves selecting the most relevant environmental impact categories and their corresponding indicators. Considering the principles outlined in ISO 14028-2016, which of the following approaches best ensures the EPD's integrity and stakeholder relevance? Assuming the material's production involves significant biomass cultivation and a novel chemical curing process. Option A. Prioritize impact categories and indicators that are directly quantifiable with readily available data for the novel curing process, even if they do not fully represent the potential upstream impacts of biomass sourcing. Option B. Adopt a minimal set of impact categories and indicators that are mandated by regional regulatory bodies, without conducting a full life cycle assessment, to expedite the EPD development process. Option C. Focus exclusively on impact categories and indicators commonly used for traditional petrochemical-based composites, as this will facilitate easier comparison for consumers familiar with existing product types. Option D. Select impact categories and indicators based on a comprehensive life cycle assessment that includes both the biomass cultivation and the novel curing process, ensuring alignment with recognized LCA databases and methodologies, and clearly documenting any limitations or assumptions. The correct answer is A. Prioritize impact categories and indicators that are directly quantifiable with readily available data for the novel curing process, even if they do not fully represent the potential upstream impacts of biomass sourcing. Explanation: ISO 14028-2016, which provides guidelines for developing environmental product declarations, EPD, emphasizes the importance of selecting appropriate environmental impact categories and indicators for a comprehensive life cycle assessment, LCA. The standard advocates for a transparent and scientifically sound selection process. Impact categories represent areas of environmental concern, such as climate change or acidification, while indicators are specific metrics used to quantify the potential environmental impact within those categories. The selection of these elements is crucial for ensuring the EPD accurately reflects the environmental performance of the product and is understandable to stakeholders. A robust selection process involves considering the product's life cycle stages, the relevance of potential impacts, the availability of reliable data, and adherence to recognized LCA methodologies, such as those outlined in ISO 14040 and ISO 14044. The chosen impact categories and indicators should be consistent with the intended audience and the environmental claims being made, avoiding both oversimplification and undue complexity. The standard also highlights the need for clear documentation of the selection rationale. Question 15. Consider a chemical manufacturing facility producing a specialized polymer as its primary output. The process also generates a significant quantity of a secondary chemical, which, while not the main focus, possesses a distinct and stable market value, contributing substantially to the overall revenue of the operation. According to the principles outlined in ISO 14028-2016 for developing environmental product declarations, which allocation method would be most appropriate for distributing the upstream environmental burdens of the raw material extraction and energy consumption between the primary polymer and this valuable secondary chemical? Option A. Allocation based on the physical mass of each output. Option B. Allocation based on the economic value of each output. Option C. Allocation based on the functional units of each output. Option D. Allocation based on the volume of each output. The correct answer is B. Allocation based on the economic value of each output. Explanation: ISO 14028-2016 provides guidance on developing environmental product declarations, EPD. When a product system involves co-products or byproducts, allocation is necessary to distribute the environmental burdens across these outputs. The standard emphasizes that the choice of allocation method should be scientifically sound, transparent, and reflect the relationship between the co-products and the main product. Among the common allocation methods, allocation based on mass or volume is often used for byproducts that have a negligible market value or are considered waste streams. However, when co-products have significant market value and are produced in substantial quantities, allocation based on economic value, e.g., market price, is generally preferred as it better reflects the polluter pays principle and the economic significance of each output. This approach aligns with the principle of distributing impacts in proportion to the value they represent in the overall production system. Therefore, for a scenario where a manufacturing process yields a primary product and a valuable co-product with a significant market price, using economic value for allocation is the most appropriate method according to the principles outlined in ISO 14028-2016, ensuring a fair and representative distribution of the system's environmental impacts. Question 16. When developing an environmental product declaration, EPD, for a prefabricated modular office building according to ISO 14028-2016, what is the most crucial consideration when defining the scope of relevant life cycle stages to ensure the EPD's integrity and comprehensiveness? Option A. Ensuring that all significant environmental impacts across the entire life cycle, from raw material extraction to end of life, are accounted for within defined system boundaries. Option B. Prioritizing only those life cycle stages that are most easily quantifiable and for which readily available data exists to expedite the declaration process. Option C. Limiting the scope to stages directly controlled by the manufacturer, excluding upstream supply chain impacts and downstream disposal considerations to simplify reporting. Option D. Focusing exclusively on the manufacturing and use phases, as these are typically perceived as having the highest direct environmental impact for building materials. The correct answer is A. Ensuring that all significant environmental impacts across the entire life cycle, from raw material extraction to end of life, are accounted for within defined system boundaries. Explanation: the development of an environmental product declaration, EPD, under ISO 14028-2016 requires a thorough life cycle assessment, LCA. Identifying relevant life cycle stages is a critical initial step in this process, directly influencing the scope and accuracy of the EPD. ISO 14028 emphasizes that all significant environmental impacts across the entire life cycle of a product should be considered. This involves a systematic approach to define the system boundaries and the specific stages to be included. The standard guides users to consider stages from raw material extraction, manufacturing, distribution, use, and end of life. A complex product like a prefabricated modular office building, this would necessitate evaluating the embodied energy and emissions associated with sourcing materials like steel, concrete, and insulation, the energy consumed during fabrication, transportation to the site, operational energy use, heating, cooling, lighting, and the potential for deconstruction, reuse, or disposal. Each stage must be analyzed for its potential environmental burden, ensuring that the EPD provides a comprehensive and transparent representation of the product's environmental performance. Failing to include a significant stage, such as the end-of-life phase for recyclable components, would result in an incomplete and potentially misleading EPD, violating the principles of ISO 14028. The objective is to capture the totality of environmental influences, not just those that are most convenient to measure. Question 17. Consider a scenario where a company is developing an environmental product declaration for a new type of advanced filtration membrane designed to purify a specific volume of industrial wastewater per day to meet stringent regulatory discharge limits, as mandated by environmental protection agencies. The primary function of this membrane is to achieve a defined level of contaminant removal over a projected operational period. Which of the following best represents the appropriate definition of the functional unit and reference flow for this product in its EPD, ensuring comparability with other filtration solutions that might achieve the same purification outcome? Option A. Functional unit, the total mass of the filtration membrane produced. Reference flow, the quantity of raw materials used in the production of 1 unit of the filtration membrane. Option B. Functional unit, the delivery of clean water, irrespective of volume or contaminant levels. Reference flow, the energy consumed during the manufacturing process of the filtration membrane. Option C. Functional unit, the lifespan of the filtration membrane in operational hours. Reference flow, the volume of wastewater processed until the membrane requires replacement, regardless of purification effectiveness. Option D. Functional unit, purification of ×X liters of wastewater per day to meet specified contaminant discharge limits for a period of ×Y years. Reference flow, the quantity of filtration membranes and associated installation components required to achieve this function over the defined period. The correct answer is D. Functional unit, purification of ×X liters of wastewater per day to meet specified contaminant discharge limits for a period of Y years. Reference flow, the quantity of filtration membranes and associated installation components required to achieve this function over the defined period. Explanation: the development of an environmental product declaration, EPD, necessitates a clearly defined functional unit and reference flow to ensure comparability and transparency. The functional unit quantifies the function delivered by the product system, serving as the basis for the EPD's impact assessment. The reference flow represents the quantity of product required to achieve the function defined by the functional unit. When a product's primary function is to provide a specific service over a defined period, the functional unit should encompass the performance characteristics and lifespan relevant to that service. For a solar panel system designed to generate a certain amount of electricity annually, the functional unit would be the generation of that specified electricity output over a defined operational lifespan. The reference flow would then be the quantity of solar panels and associated installation materials required to achieve this generation target. This approach ensures that different solar panel systems, even with varying efficiencies or degradation rates, can be compared on an equivalent basis, facilitating informed decision-making for consumers and specifiers. The selection of an appropriate functional unit and reference flow is crucial for the integrity and utility of the EPD, aligning with the principles of ISO 14028-2016, which emphasizes clarity, comparability, and scientific rigor in environmental declarations. This systematic approach allows for a comprehensive assessment of environmental impacts across the entire life cycle, from raw material extraction to end-of-life management, as relevant to the defined function. Question 18. When developing an environmental product declaration, EPD, for a novel composite material, what approach to data collection for the raw material extraction phase would best align with the principles of ISO 14028-2016, considering the material's unique composition and limited existing industry data? Option A. Conduct on-site audits and collect primary data directly from the mines and extraction sites of each raw material component, even if this requires extensive international travel and significant logistical challenges. Option B. Rely solely on generic industry average data for similar material types, as specific extraction data for this novel composite is unavailable, and this approach simplifies the data collection process. Option C. Utilize a comprehensive life cycle inventory (LCI) database that includes specific entries for each constituent raw material, sourced from reputable academic research and peer-reviewed geological surveys, and clearly document any assumptions made regarding the extraction processes. Option D. Employ a qualitative assessment based on expert opinion and anecdotal evidence regarding the environmental impacts of raw material extraction for similar materials, without the need for quantitative data. Correct answer is C. Utilize a comprehensive life cycle inventory (LCI) database that includes specific entries for each constituent raw material, sourced from reputable academic research and peer-reviewed geological surveys, and clearly document any assumptions made regarding the extraction processes. Explanation: the development of an environmental product declaration (EPD) under ISO 14028-2016 necessitates rigorous data collection for all relevant life cycle stages of a product. ISO 14028 emphasizes the importance of using reliable and verifiable data sources. Primary data, collected directly from the manufacturing processes and operational use of the product, offers the highest level of specificity and accuracy. This includes direct measurements of energy consumption, material inputs, emissions, and waste generation during production. For the use phase, primary data might involve surveys or direct monitoring of product performance and end-of-life handling by consumers or industrial users. Secondary data, sourced from databases, industry averages, or literature, can be used to supplement primary data, particularly for life cycle stages where direct measurement is impractical or prohibitively expensive, such as raw material extraction or transportation over long distances. However, the standard requires that secondary data be as representative as possible of the specific product system under study, and that its use be justified. The selection of data sources must align with the principles of ISO 14040 and ISO 14044, which underpin EPD development, ensuring transparency and credibility. The chosen data must be appropriate for the defined system boundaries and the intended audience of the EPD. A robust EPD relies on a balanced approach, prioritizing primary data where feasible and using well-documented, representative secondary data judiciously, with clear justification for its inclusion. Question 19. Consider a biorefinery that processes agricultural biomass to produce both a high-value biofuel and a lower-value animal feed coproduct. Both outputs are sold on the market, and the process generates significant environmental impacts, such as greenhouse gas emissions and water consumption. According to the principles outlined in ISO 14028-2016 for developing environmental product declarations, what is the primary basis for allocating the environmental burdens of the biorefinery's processes to the biofuel and the animal feed when a physical relationship is not directly quantifiable for burden distribution? Option A. Allocation based on the energy content of the biofuel and the animal feed. Option B. Allocation based on the proportion of labor and capital invested in the production of each output. Option C. Allocation based on the relative market value of the biofuel and the animal feed at the time of production. Option D. Allocation based on the mass or volume of the biofuel and the animal feed produced. The correct answer is C. Allocation based on the relative market value of the biofuel and the animal feed at the time of production. Explanation: ISO 14028-2016, in its guidance for developing environmental product declarations, EPD, addresses the complex issue of allocation for multifunctional processes. A multifunctional process is one that produces more than one output, or at least one output is an elementary or co-product. When developing an EPD for one of these outputs, it is necessary to allocate the environmental burdens associated with the process to the various outputs. ISO 14028-2016 outlines that allocation should be based on physical relationships or, in the absence of such, on economic value. The standard emphasizes that the chosen allocation method should be scientifically justifiable and clearly documented within the EPD. For instance, if a chemical process yields both a primary product and a byproduct, and the byproduct has a market value, allocation based on the economic value of the primary product versus the byproduct would be a common approach. Conversely, if the outputs are directly proportional to a physical input, such as a milling process producing flour and bran, allocation based on mass or volume might be more appropriate. The overarching principle is to ensure that the environmental burdens are distributed in a way that reflects the relative significance of each output, thereby preventing the shifting of environmental burdens between products. The goal is to provide a fair and transparent representation of the environmental performance of the product for which the EPD is being prepared. The standard also encourages the use of system expansion where feasible, as this can avoid allocation altogether by treating the co-products as separate systems. However, when allocation is necessary, adherence to the hierarchy of physical relationships followed by economic value is paramount for consistency and comparability of EPDs. Question 20. When developing an environmental product declaration, EPD, for a composite building material, a life cycle inventory, LCI analysis reveals a manufacturing process that yields both the primary product and a significant co-product used in a different industry, according to the principles outlined in ISO 14028-2016, for developing EPDs and referencing broader life cycle assessment methodologies, which approach for allocating environmental burdens associated with the shared manufacturing inputs is generally considered the most robust and preferred method when a direct causal relationship between the inputs and outputs is demonstrable. Option A. Allocation based on a direct physical relationship, such as the proportion of energy consumed per unit of primary product versus co-product, if such a relationship can be scientifically substantiated. Option B. Allocation based on the mass of the primary product compared to the mass of the co-product. Option C. Allocation based on the economic value of the primary product relative to the co-product at the point of production. Option D. A 50/50 split of all shared environmental burdens between the primary product and the co-product, irrespective of their production volumes or market values. The correct answer is A. Allocation based on a direct physical relationship, such as the proportion of energy consumed per unit of primary product versus co-product, if such a relationship can be scientifically substantiated. Explanation. The core principle of ISO 14028-2016 regarding life cycle inventory, LCI analysis for environmental product declarations, EPD, is the comprehensive data collection across all relevant life cycle stages. This includes inputs of energy and materials, as well as environmental releases to air, water, and land. The standard emphasizes the importance of defining the functional unit and system boundaries to ensure comparability and relevance. When considering the allocation of environmental burdens in a multi-output process, ISO 14028-2016, in alignment with ISO 14044, suggests prioritizing allocation based on physical relationships, followed by mass or economic value, if physical relationships are not applicable or sufficient. The objective is to distribute the environmental impacts in a scientifically sound and transparent manner that reflects the underlying cause of the impacts. For instance, if a process produces two co-products, the energy consumed and emissions generated by that process should be allocated between the co-products. If there's a clear physical link, such as a direct causal relationship in energy consumption per unit of product, that would be the preferred method. If not, allocation based on mass or economic value becomes the next consideration, with the chosen method needing clear justification within the EPD. This ensures that the LCI accurately represents the environmental performance of the specific product being declared, avoiding double counting or underreporting of impacts. The overarching goal is to provide credible and comparable environmental information to stakeholders. Question 21. When developing an environmental product declaration, EPD, in accordance with ISO 14025, which fundamental principle ensures that the declared environmental information is reliable, based on sound scientific methodology, and subject to independent scrutiny to foster trust and facilitate informed decision-making by stakeholders? Option A. Adherence to independent third-party verification and transparency in data and methodology. Option B. Exclusively relying on primary data collected directly from the manufacturing process. Option C. Prioritizing marketing claims over the strict adherence to life cycle assessment principles. Option D. Utilization of a broad range of environmental impact categories, regardless of product specificity. Correct answer is A. Adherence to independent third-party verification and transparency in data and methodology. Explanation. ISO 14025 establishes the framework for Type Roman III environmental declarations, often referred to as environmental product declarations, EPD. A core principle guiding the development and verification of EPDs under this standard is the assurance of credibility and comparability. This credibility is built upon a robust foundation of scientific rigor, transparency, and adherence to established international standards, particularly ISO 14040 and ISO 14044 for life cycle assessment, LCA. The standard mandates that the data used in an EPD must be representative, verifiable, and based on a functional unit that allows for meaningful comparison between similar products. Furthermore, the verification process, typically conducted by an independent third party, ensures that the EPD accurately reflects the environmental performance of the product as determined by the LCA and complies with the program operator's rules. The principle of transparency means that all methodological choices, assumptions, and data sources used in the LCA and EPD development must be clearly documented and accessible. Comparability is achieved by requiring that EPDs for similar products follow the same product category rules, PCR, which define the specific LCA methodology and data requirements for a given product group. This ensures that consumers and stakeholders can make informed decisions based on like-for-like environmental performance data. Without these foundational principles, the integrity and utility of EPDs would be compromised, hindering their effectiveness in promoting environmentally preferable products. Question 22. When developing an environmental product declaration, EPD, for a novel composite building material intended for international export and aiming to facilitate comparison with existing products in diverse regulatory environments, what is the most critical initial step in defining the life cycle assessment, LCA framework, to ensure its robustness and applicability? Option A. Selecting impact assessment methods solely based on their widespread recognition in the European Union market, irrespective of their suitability for other target regions. Option B. Precisely defining the functional unit and clearly delineating the system boundaries, including the cradle-to-gate or cradle-to-grave scope, while considering relevant international standards and potential sector-specific product category rules, PCR. Option C. Identifying all potential environmental impacts across every conceivable life cycle stage, even those with negligible contributions, to ensure a comprehensive data collection effort. Option D. Prioritizing the collection of primary data for all life cycle inventory, LCI, processes, even if secondary data is readily available and of sufficient quality for certain stages. The correct answer is B. Precisely defining the functional unit and clearly delineating the system boundaries, including the cradle-to-gate or cradle-to-grave scope, while considering relevant international standards and potential sector-specific product category rules, PCR. Explanation. The core principle of defining the goal and scope for an environmental product declaration, EPD, under ISO 14028-2016, is to establish the context and boundaries for the entire life cycle assessment, LCA. This process is critical for ensuring the EPD's relevance, comparability, and credibility. The goal statement should clearly articulate the intended application of the EPD, the target audience, and the reasons for conducting the LCA. For instance, if the EPD is intended for business-to-business communication to inform procurement decisions regarding building materials, the goal would reflect this. The scope definition then translates the goal into specific parameters for the LCA. This includes defining the functional unit, which is a quantified measure of the function delivered by the product system, the system boundaries, which determine which life cycle stages and processes are included, the allocation procedures for dealing with co-products and recycling, and the data quality requirements. For example, if the goal is to compare two types of insulation for a residential building, the system boundary might extend from raw material extraction through manufacturing, transportation, installation, use, including energy consumption during use, and end-of-life disposal or recycling. The choice of functional units, such as providing thermal resistance to a standard wall assembly for a 60-year service life, is crucial for fair comparison. Furthermore, the scope must also consider any specific requirements from relevant standards or regulations, such as those outlined in ISO 14040 and ISO 14044 for LCA methodology, and any sector-specific product category rules, PCR, that provide detailed guidance for developing EPDs for particular product groups. The scope also dictates the impact categories to be assessed and the impact assessment methods to be used. A well-defined scope ensures that the LCA is conducted in a consistent and transparent manner, directly supporting the stated goal of the EPD. Question 23. When a consortium of manufacturers in the building materials sector decides to develop an environmental product declaration, EPD, for a new composite wood panel, adhering to the principles outlined in ISO 14028-2016, what is the most crucial foundational step to ensure the declaration's integrity and credibility with regulatory bodies and discerning purchasers, particularly in regions with stringent environmental marketing regulations like the European Union's Unfair Commercial Practices Directive? Option A. Creating a visually appealing marketing brochure that highlights the product's positive environmental attributes without detailed data. Option B. Conducting a comprehensive life cycle assessment (LCA) that is independently verified and aligns with ISO 14040 and ISO 14044 standards. Option C. Focusing solely on the recyclability of the product at its end-of-life phase, as this is a key consumer concern. Option D. Developing a proprietary internal scoring system to rank the environmental performance of different panel formulations. The correct answer is B. Conducting a comprehensive life cycle assessment (LCA) that is independently verified and aligns with ISO 14040 and ISO 14044 standards. Explanation: the fundamental principle of environmental labeling, as guided by ISO 14028-2016, emphasizes transparency and verifiability. When developing an environmental product declaration (EPD), a critical aspect is ensuring that the underlying data and methodologies used are robust and can withstand scrutiny. This involves a thorough life cycle assessment (LCA) that adheres to relevant ISO standards, such as ISO 14040 and ISO 14044. The declaration itself must be comprehensive, covering all significant environmental impacts across the product's life cycle, from raw material extraction to end of life. Furthermore, the communication of this information to consumers and stakeholders must be clear, accurate, and not misleading. This means avoiding unsubstantiated claims and ensuring that any comparative assertions are based on equivalent data sets and methodologies. The credibility of an EPD hinges on its adherence to these principles, which are designed to prevent greenwashing and foster genuine environmental improvement. The standard specifically advocates for the use of recognized third-party verification to enhance the trustworthiness of the EPD. This verification process scrutinizes the LCA methodology, data quality, and the final declaration to ensure compliance with the standard and the integrity of the environmental information presented. The ultimate goal is to empower informed purchasing decisions and drive market demand for more environmentally sound products. Question 24. Consider a scenario where a manufacturer of prefabricated building modules is developing an environmental product declaration (EPD) according to the principles outlined in ISO 14028-2016. They are debating the extent to which the module's operational phase, specifically energy consumption during its use in a building, should be included in the EPD. Product category rules (PCR) for this building material sector are still under development but are expected to align with ISO 14025. Which of the following approaches best reflects the critical consideration for defining the system boundary in this context, ensuring the EPD's integrity and comparability? Option A. The system boundary should be extended to include the entire operational life of the module, regardless of the PCR, to provide the most comprehensive environmental information, even if it necessitates extensive assumptions about energy sources and usage patterns. Option B. The system boundary must be defined to encompass all life cycle stages that contribute significantly to the product's environmental footprint, as determined by the evolving PCR, and this definition must be explicitly declared within the EPD. Option C. The system boundary should be determined solely by the manufacturer's internal environmental management system, prioritizing only those life cycle stages where the company has direct influence over environmental performance to avoid external variables. Option D. The system boundary should be limited to the cradle-to-gate phase to simplify data collection and reporting, as the operational energy consumption is highly dependent on the end user's behavior and building design, which are beyond the manufacturer's direct control. The correct answer is B. The system boundary must be defined to encompass all life cycle stages that contribute significantly to the product's environmental footprint, as determined by the evolving PCR, and this definition must be explicitly declared within the EPD. Explanation: the development of an environmental product declaration, EPD, under ISO 14025-2006, which ISO 14028-2016 builds upon and references for core principles, necessitates a clear and consistent definition of the system boundary. The system boundary dictates which life cycle stages and processes are included in the environmental assessment. A broader system boundary, encompassing more life cycle stages, e.g., cradle to grave, generally leads to a more comprehensive environmental profile but can also increase complexity and data requirements. Conversely, a narrower boundary, e.g., cradle to gate, might simplify the assessment but could omit significant environmental impacts occurring after the product leaves the factory. The choice of system boundary is a critical decision made during the EPD development planning phase, often guided by the product category rules (PCR) and the intended use of the EPD. It directly influences the scope of the life cycle assessment (LCA) and consequently the reported environmental indicators. For instance, including end-of-life treatment processes like landfilling or incineration, which are part of a cradle-to-grave boundary, will likely result in different impact category results compared to an assessment that stops at the factory gate. Transparency regarding the defined system boundary is paramount in an EPD, allowing users to understand the scope of the assessment and compare EPDs appropriately. The alignment of the system boundary with the relevant PCR is a fundamental requirement for ensuring comparability and credibility of EPDs. Question 25. When developing an environmental product declaration, EPD, for a novel composite material used in aerospace construction, what fundamental data quality characteristic, as stipulated by ISO 14028-2016, should be prioritized to ensure the declaration accurately reflects the material's environmental footprint across its entire life cycle, particularly given the limited availability of specific primary data for this emerging material? Option A, representativeness. Option B, verifiability. Option C, consistency. Option D, accuracy. The correct answer is A, representativeness. Explanation: ISO 14028-2016, concerning environmental labels and declarations, specifically addresses the development of environmental product declarations, EPD. A critical aspect of EPD development is ensuring the reliability and credibility of the data used. The standard emphasizes that data used in an EPD should be as representative as possible of the product's life cycle. This involves several key principles for data quality. Firstly, data should be relevant to the declared environmental performance and the intended use of the product. Secondly, data should be accurate, meaning it reflects the actual environmental impacts with minimal bias. Thirdly, data must be complete, covering all significant life cycle stages and environmental impact categories relevant to the product type. Fourthly, data should be consistent in its methodology and application throughout the EPD. Finally, data needs to be traceable and verifiable, allowing for independent review and confirmation of its source and validity. When assessing data quality for an EPD under ISO 14028-2016, the primary consideration is the extent to which the data aligns with these principles, ensuring the EPD provides a transparent and credible representation of the product's environmental profile. This includes evaluating the age of the data, its geographical applicability, and whether it originates from primary or secondary sources, prioritizing primary data where feasible and representative. Question 26. Consider a scenario where an EPD developer for a novel composite material, utilizing a recently patented manufacturing process, needs to account for the energy consumption of a specific chemical precursor. The only available data for this precursor's production comes from a 2005 industry report detailing average energy use for a similar, but not identical, chemical produced in a different geographical region using older technology. According to the principles outlined in ISO 14028-2016, what is the most appropriate approach for the EPD developer to take regarding the use of this secondary data? Option A. Document the source, age, and geographical origin of the data. Clearly state the assumptions made in adapting it to the specific precursor and process, and justify its use by demonstrating that no more representative data is available, while also assessing the potential impact of these limitations on the EPD's results. Option B. Seek out and utilize primary data for the precursor's energy consumption, even if it requires extensive and costly primary data collection for a component that represents a minor part of the overall product's life cycle. Option C. Exclude the precursor's energy consumption from the EPD altogether, as the data is not directly from the product system and lacks sufficient specificity to the new manufacturing process. Option D. Use the 2005 industry report data without modification, assuming it is representative of current conditions and the specific precursor, to ensure a complete dataset for the EPD. The correct answer is A. Document the source, age, and geographical origin of the data. Clearly state the assumptions made in adapting it to the specific precursor and process, and justify its use by demonstrating that no more representative data is available, while also assessing the potential impact of these limitations on the EPD's results. Explanation: ISO 14028-2016 provides guidelines for the development of environmental product declarations (EPD). A key aspect of EPD development is the use of data, which can be either primary or secondary. Primary data is collected directly from the specific product system under study, reflecting its actual processes and resource inputs/outputs. Secondary data, on the other hand, is data that has been collected for other purposes or from other sources, such as industry averages, databases, or literature. When secondary data is used in an EPD, it is crucial to ensure its relevance, representativeness, and quality to maintain the integrity and credibility of the EPD. ISO 14028 emphasizes that secondary data should be as specific as possible to the product system being declared and should be documented thoroughly, including its source, age, geographical scope, and any assumptions made during its collection or adaptation. The standard also requires justification for the use of secondary data and an assessment of its potential impact on the overall results of the life cycle assessment, LCA, underpinning the EPD. The goal is to minimize uncertainty and ensure that the EPD accurately reflects the environmental performance of the declared product. The use of generic or outdated secondary data without appropriate justification or adaptation can lead to misleading EPDs and undermine the comparability and reliability of environmental information. Therefore, a critical evaluation and careful selection of secondary data are paramount for compliance with ISO 14028. Question 27. When a manufacturing firm is developing an environmental product declaration, EPD, for its new line of sustainable building materials, adhering to the principles outlined in ISO 14028-2016, what fundamental consideration regarding its compatibility with other environmental labeling and declaration schemes is paramount for maximizing the EPD's international acceptance and utility? Option A. Limiting the scope of the EPD to only those environmental impacts that are explicitly mandated by national regulations within the primary market of sale, regardless of international standards. Option B. Prioritizing the inclusion of proprietary environmental performance metrics that differentiate the product uniquely, even if these metrics are not recognized by other global declaration systems. Option C. Focusing exclusively on the verification process conducted by a single, nationally recognized third-party certifier, without considering the recognition of that certifier by international bodies. Option D. Ensuring the EPD's underlying life cycle assessment, LCA, methodology and data are aligned with or verifiable by other established international Type III environmental declaration programs and relevant ISO standards for LCA. The correct answer is D. Ensuring the EPD's underlying life cycle assessment, LCA, methodology and data are aligned with or verifiable by other established international Type III environmental declaration programs and relevant ISO standards for LCA. Explanation: ISO 14028-2016 provides guidance on the development of environmental product declarations, EPD. A key aspect of this standard is its relationship with other environmental labeling and declaration schemes. The standard emphasizes that EPDs developed according to ISO 14025, which ISO 14028 complements, should be compatible with and ideally verifiable by other relevant environmental programs. This compatibility ensures that the information provided in an EPD is credible and can be recognized across different markets and regulatory frameworks. Specifically, ISO 14028 addresses the need for transparency and comparability, which are enhanced when an EPD aligns with recognized international standards and methodologies, such as those used by other Type Roman III environmental declaration programs or relevant ISO standards for life cycle assessment, LCA. The goal is to avoid creating isolated or proprietary systems that hinder broader acceptance and understanding of environmental product information. Therefore, when developing an EPD under the principles of ISO 14028, the practitioner must consider how the EPD's content and verification process will interface with existing or emerging global environmental labeling and declaration initiatives, ensuring that the EPD can contribute to a harmonized approach to communicating environmental performance. This includes considering the underlying LCA methodology, data requirements, and verification procedures to ensure they meet the expectations of other recognized schemes, thereby fostering greater trust and utility for the EPD. Question 28. Consider a manufacturing process that produces a primary chemical compound intended for industrial solvents and a secondary material, a purified mineral residue, which has a significantly lower market value and is primarily sold for use as a low-grade aggregate. The market value of the primary chemical compound is 1,000 currency units per ton, while the market value of the mineral residue is 50 currency units per ton. The total environmental burden associated with the combined production of 1 ton of the primary chemical compound and the corresponding amount of mineral residue is 105 environmental impact units. According to ISO 14028-2016 guidelines for allocation in environmental product declarations, which method would be most appropriate for distributing this burden to reflect the environmental performance of the primary chemical compound, and what would be the allocated impact to the primary chemical compound? Option A. Allocation based on energy input, assuming equal energy consumption for both outputs, resulting in approximately 52.5 environmental impact units allocated to the primary chemical compound. Option B. Allocation based on mass, assuming a 1:1 mass ratio, resulting in approximately 52.5 environmental impact units allocated to the primary chemical compound. Option C. Allocation based on physical relationships, assuming the mineral residue is an unavoidable byproduct with no intrinsic value, resulting in 0 environmental impact units allocated to the primary chemical compound. Option D. Allocation based on economic value, resulting in approximately 100 environmental impact units allocated to the primary chemical compound. The correct answer is D. Allocation based on economic value, resulting in approximately 100 environmental impact units allocated to the primary chemical compound. Explanation. ISO 14028-2016, in its guidance for developing environmental product declarations, EPD, addresses the complex issue of allocation for multifunctional processes, which are processes that yield more than one product or co-product. The standard emphasizes that when a process has multiple outputs, environmental impacts must be distributed among these outputs in a scientifically sound and justifiable manner. The core principle is to reflect the functional relationship between the primary product and any co-products. ISO 14028-2016 outlines several allocation methods, including allocation based on mass, economic value, or physical relationships. The choice of method should be transparent and documented within the EPD. When a process generates a primary product and a co-product with a clear, direct physical relationship, such as a chemical reaction where one substance is the intended output and another is an unavoidable byproduct, allocation based on physical relationships or mass is often preferred if it accurately reflects the contribution of each output to the environmental burden. For instance, if a refining process yields both gasoline and a residue that can be sold as asphalt binder, and the mass ratio is a significant factor in their production, allocating impacts based on mass might be appropriate if the economic value disparity is not extreme. However, if the economic value of the co-product is significantly lower, and it is primarily considered a byproduct with limited market demand or utility, allocating a minimal portion of the environmental burden to it might be considered, provided it is justified by the economic value. The standard encourages the use of methods that best represent the environmental burden associated with the intended function of the primary product. In a scenario where a process produces a primary product and a co-product with vastly different economic values, and the co-product has a significantly lower market value, allocation based on economic value is a common and accepted practice to ensure the EPD for the primary product accurately reflects its environmental performance without being unduly burdened by the impacts associated with the lower value co-product. Therefore, if a process yields a primary product with a market value of 1,000 units and a co-product with a market value of 50 units, and the total environmental burden of the process is 105 units, the allocation to the primary product would be frac 1,000 plus 50 times 105 equals frac 1,000 50 times 105 equals 0. 95,238 times 105 approx 100 units. This approach ensures that the EPD for the primary product reflects the majority of the environmental burden, aligning with its economic significance and intended function. Question 29. Consider a manufacturer of high-efficiency solar panels where slight variations in silicon crystal structure across different production batches can lead to minor, but measurable, differences in energy conversion efficiency. According to the principles outlined in ISO 14028-2016 for developing environmental product declarations, how should this inherent product performance variability be addressed to ensure the EPD remains accurate and transparent for downstream users assessing the environmental footprint of their energy generation? Option A. Quantify the variation by creating separate EPDs for each distinct production batch, provided there are more than 5 identified variations in efficiency across the batches. Option B. Clearly communicate the observed range of energy conversion efficiencies for the product, potentially by providing a statistical distribution or a minimum/maximum efficiency benchmark, alongside the primary life cycle impact data. Option C. Exclude any mention of efficiency variations in the EPD, as the differences are minor and within typical industry tolerances, focusing solely on the declared average life cycle impact. Option D. Report a single, statistically derived average efficiency value for all panels produced within a defined period, without further qualification on the range of variation. Correct answer is D. Report a single, statistically derived average efficiency value for all panels produced within a defined period, without further qualification on the range of variation. Explanation: ISO 14028-2016 provides guidance for developing environmental product declarations (EPD). A critical aspect of EPD development, especially for products with inherent variability or performance differences across units or batches, is how to represent this variation accurately and transparently. The standard emphasizes that EPDs should reflect the environmental performance of the product as it is placed on the market. When a product's performance characteristics, such as energy efficiency, durability, or emissions, can vary between individual units or production batches due to manufacturing tolerances, material sourcing variations, or operational conditions, this variability must be addressed. The standard suggests that if such variations are significant and impact the environmental performance declared, they should be communicated. This communication can be achieved by providing a range of values, statistical distributions, or clearly defined conditions under which the declared performance is achieved. The goal is to ensure that the EPD is representative of the actual product and does not mislead users. For instance, if a batch of insulation material exhibits a range of thermal conductivity values, an EPD should ideally reflect this range rather than a single averaged value, unless the average is demonstrably representative of the vast majority of products, and the deviations are minor and within acceptable engineering tolerances that do not materially alter the environmental impact assessment for typical use. The standard does not mandate specific statistical methods, but stresses the importance of transparency and representativeness in communicating environmental information. Question 30. When developing an environmental product declaration, EPD, for a novel biocomposite building material that is manufactured at multiple geographically dispersed facilities using varied agricultural feedstocks, what is the most critical consideration regarding data uncertainty and variability as stipulated by ISO 14028-2016 for ensuring the declaration's integrity and usability? Option A. Implementing a rigorous statistical analysis to eliminate all data variability, thereby presenting a single, definitive environmental performance figure. Option B. Focusing solely on the uncertainty associated with the end-of-life phase, as this is typically the most variable component of a product's life cycle. Option C. Exclusively relying on average data values across all facilities to present a simplified and easily comparable environmental profile. Option D. Quantifying and transparently communicating the range of significant environmental impacts arising from variations in feedstock characteristics and manufacturing site-specific conditions. The correct answer is D. Quantifying and transparently communicating the range of significant environmental impacts arising from variations in feedstock characteristics and manufacturing site-specific conditions. Explanation: ISO 14028-2016 concerning environmental labels and declarations emphasizes the critical importance of addressing data uncertainty and variability throughout the development of environmental product declarations, EPD. When establishing the scope and methodology for an EPD, particularly for a complex product system like a novel biocomposite building material, understanding and managing data variability is paramount. This involves identifying sources of variation, such as differences in raw material extraction, manufacturing processes across different sites, and end-of-life treatment methods. ISO 14028-2016 advocates for a systematic approach to characterizing this variability, often through statistical methods, to ensure the robustness and reliability of the declared environmental information. The standard suggests that, where significant variability exists, it should be quantified and communicated to the user of the EPD. This aids in providing a more transparent and realistic representation of the product's environmental performance, preventing oversimplification or misinterpretation. For instance, if the energy consumption during the manufacturing phase of the biocomposite varies by more than 10% across different production batches due to variations in feedstock moisture content, this range of energy consumption should be considered and potentially reported. The goal is to provide a comprehensive picture that reflects the real-world performance, acknowledging that a single, fixed value might not fully capture the product's environmental footprint. This proactive management of uncertainty ensures the EPD serves its intended purpose of informing decision-making based on credible environmental data.